is Untitled Chapter and my metric number is BDA31003 and I am FKMP student.
Hello, my name is Untitled Chapter. My metric card number is AD170061 and I am from FKMP.
Hi, my name is Shamil Hakim bin Muhammad Hamzani. My metric number is AD170080 and I am from FKMP.
Hi, my name is Amirul Amin bin Abdul Razak. My metric number is AD170177 and I'm from FKMP.
Hello, I am Noatira Atasha binti Ismail and now I will proceed with the introduction of this project. As for the introduction of this project, our group has decided to choose heatsink as our heat exchanger. Mainly, heatsink function to cool down the CPUs, GPUs and some chipset in the computer. It is designed with the maximum surface area between the fins that gives the best cooling medium to its surroundings. The main purpose of this project is to analyze the original design of the heat exchanger with a new design and compare the parameters and its characteristics. 3 parameters of the heat exchanger have been selected, which is types of fins, size of fin, and the number of fins.
Hello everyone, first of all, let me introduce myself. My name is Tajul Maidin bin Sini Ibrahim and today I'm gonna explain to you the result that we obtained from the Lisa 7.7 software for the rectangular fins, which is the original design of the project. So on the left hand side, we have temperature distribution of the original design. The heat transfer from the base to the fin top is decreasing gradually. Base temperature 50 degrees Celsius and in the middle of the fin, the temperature was around 45.51 degrees Celsius to 46.5 degrees Celsius. Analysis successfully satisfied the theoretical concept of a fin. On the right hand side, which is our heat flux magnitude of the original design. Magnitude mostly covered up with purple color and magenta color as a value 39.37 watt per meter square and 0.1337 watt per meter square respectively. Hello, so in this project, we are expected to find the value of heat flow rate Q dot and the overall heat transfer coefficient U. The nodes chosen for temperature distribution were 112, 111 and 128. As for the heat flux magnitude, the nodes chosen were 569, 387 and 60. As you can see, average temperature distribution were calculated and we obtained the answer in Kelvin, which is 315.73571 Kelvin. And for the average heat flux magnitude, the answer was 329.3979 watt per meter square. So here the next slide. So as you can see, the calculation for the heat flow rate and also the overall heat transfer coefficient were shown step by step, and the answer that obtained for the total heat flow rate is 0.0004886 watt, and also for the overall heat transfer coefficient is U equals to 0.001579 watt per meter square Kelvin.
My name is Shahmil and I will resume with the triangular fins analysis. From the analysis, we found the temperature distribution and the heat flux magnitude. Our initial temperature is 50 degrees Celsius. From the temperature distribution, we found that in the middle of the fin, the temperature was dropped around 43 degrees Celsius to 46 degrees Celsius. And at the tip of the fin, we also found that there are cooler temperature, which is around 37 to 39 degrees Celsius. And for our heat flux magnitude of the improved design, we found that the heat flux magnitude mostly cover up with the purple color and magenta color as the value 39.37 watt per meter square and 0.1337 watt per meter square respectively. However, the last fin cover up with the several colors. This means that there are higher heat flux magnitude at that point. Before we start our calculation for our triangle fins, note that the material properties value for this improved design is the same as original design. And our average temperature distribution from our nodes is 311.878895 Kelvin. and our average heat flux magnitude Q is equal to 396.05603 watt per meter square. So we resume with our heat flow rate. Heat flow rate, we must find the total heat flow rate from Q unfin and Q fin. From the calculation, we found that Q unfin is 4.788 watt and our Q fin from the derivation is 0.0218 watt and our total is 4.984 watt. So from this, we divided by time, which is 10,000 seconds, we get the total heat flow rate is 0.0004984. And our overall heat transfer coefficient, which is the equation of Q dot equal to U A theta T. We rearrange the formula and put the value from our calculation, we'll get 0.001631 watt per meter square Kelvin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Amin bin Abdul Razak, AD170177, and today I'm going to talk about the graph of heat flow rate versus types of fins. Okay, this is taken from the chapter 5, optimization, comparison, and the discussion. So the first point is, due to its shapes and size, triangular fins show that as a dimension increase, the heat flow rate also increase compared to the rectangular fins as illustrated in figure 5.7. So for the figure 5.8, which is the graph of overall heat transfer coefficient versus type of fins, it is directly proportional to the heat flow rate based on type of fins. The heat flow rate increase, the overall heat transfer coefficient will also increase. So the comparison by the software LISA also proved that the thermal analysis improved from the modification analysis. For the result, and based on the result, the improved design of the heat exchanger recorded the highest value of heat flow rate and the overall heat transfer coefficient. It shows that our group suggestion to improve both values of heat flow rate and overall heat transfer coefficient have been succeeded. So this is all the result. It shows the original design and the improved design, and all the parameters which we already recorded. So thank you.